Welcome. I'm getting a little bit of a late start on the semester. Just a lot of things landed on my plate last week, and I'm finally getting to the introduction video here. So here we are. Welcome to the class. Thank you for getting involved in our first classroom discussion. And I wanted to walk through kind of what we have so far, and then also kind of the general plan of where we're headed over the next 14 weeks to explore dynamics. Like, what is dynamics? And that's kind of what we're asking here. It's like, what is dynamics? How do we apply it? What are we working on? Cool. So this is what we have so far. We're gonna build. I'll keep building stuff in Husky CT as the semester continues. But so far we have a link to my website. So I'll open this. Have it open in this tab. This is where you can go to set up an appointment. So if you want to talk about either things in the class, or if you have questions about how this class applies to different careers and those kind of things, we can look at that. The YouTube channel. So this is where like all of my YouTube channels are. Right now we have this dynamics. It's live. So I'll start scheduling times where I do these live streams. You're welcome to join, or you can watch them after the fact. It's up to you. You're not required to join when I have these live sessions. It's just live stream is kind of a nice way to just add some content and do some stuff. So the main like playlist that we're working on together is this Dynamics-Live. So I'm recording something right now, but there's also these other two videos so far. So and again, I'll keep recording stuff. I'll keep streaming new stuff, and if you want to join, you're welcome to. Otherwise, you can watch the recorded videos. Cool. So we have that. Then we have our dynamics syllabus. So let's open this in a new tab. I'm building this website with Julia since I want to transition this class. I've used Python and Jupyter in the past, but Julia is a really high performance, and I want to say easy to use. It is easier to use than most programming languages. It's really cool. I love a lot of the ways that they integrate like math, like actual math equations into the language. So the goal here is learn some dynamics by coding. So we're coding to learn dynamics. We're not like learning all the ins and outs of coding in Julia. There's lots of like cool things that you can do, and it can get very complicated, or we can kind of keep it simple and use some tools. So the depth of programming that you get into, that's kind of up to you. And you can always call upon other people in the class. Now we even have like AI support for tools. And yeah, so there's that too. And I'll launch up Julia and what's it called? And Pluto, and show you you can actually like run some AI queries there too. I think by default it runs it, but anyway, we'll try it. Cool. We'll submit assignments through Husky CT. The goal here is building more of a portfolio of work. So working together, building some projects on stuff. There will be some check-in assignments. So we already have one check-in of just engaging with that the first discussion. So I'll show you what I mean here. Let's go into, I think this is switch to student preview. Yeah, start preview. Okay, so now I'm in preview mode. There's a getting started, and it says join our GitHub discussions. Okay. I don't love this about the Ultra, that Ultra does this, but it doesn't give you the instructions until you say view instructions, but really that's probably the only thing you want to do is like know how to do the assignment. But this is how you do it. Click view instructions, and now it says copy the link to your GitHub discussion post, add it here. include your username as well. So my username is CooperRC, so I'm going to copy that down, paste it in here. If you want to get fancy, I like getting fancy, you can actually add a link. Oh, you can add any website, but here in particular, I'll say github.com/CooperRC, and that would, not GTI, GIT, like that, insert. And now I've got that CooperRC link, and then I want my discussion post. So where is that discussion post? So in GitHub discussions, brings me, so far we've only had like one discussion. Feel free to add other questions, and this is my preferred interaction, that if you have questions about like the class or concepts or even logistics, post it in this discussion board and we can answer that way. Doing emails like back and forth, volleying emails, it just doesn't work. It's not sustainable. There are 85 people in the class, and we only have 3/4 of a TA. It's been a transition semester this year. Things are a little different. Okay, but anyway, so here's the link to this first discussion. This was my first post, but I also have some other posts that I was kind of working on. So let me grab this one. I'll copy this link. If this was your link, thanks, Mohammed, you could copy that link there. So I'm going to grab mine to say, hey, this is what I answered. And again, if you want to get fancy, you don't have to, but you could say, this is my link URL, and down here, this is my link text, and insert it there. And that would be it. That's the submission for that first kind of check-in of like, hey, how are you doing in the class? Cool. So there's that. Now let's get back to syllabus. So this course is studying kind of moving objects and how they interact. So main thing there is kind of like, what is multi-body dynamics? That's what we're trying to build towards. Is we're gonna introduce some ideas of Lagrangian mechanics and then kind of build on that to talk about like what happens when we have multiple parts interacting, and how do we code for that. So there's the general process is called multi-body dynamics simulations, like MBD, and that would be like atoms and rigid body dynamics. So all of this class is all like rigid body kind of work. We're not dealing with like solid objects that are vibrating, or like solid mechanics of vibrating objects. They are solid and they can vibrate, but they are not stretching, if that. So this class, we're just dealing with things that stretch would be like springs, but usually in dynamics they're considered like massless springs. So they're just applying force, they don't actually have momentum. Same thing with like dampers and other kind of forces like that. So I said this website is built with Julia, and I'll keep adding to it throughout the semester as we're kind of building some things together. So we're going to build engineering models. We'll use some vectors and calculus. Our main goal is getting to like equations of motion, of just how do we describe motion and constraints on motion. So the vector, no matter what, motion is always defined with vectors like position and velocity, but we won't have to deal with vectors as much as Newtonian mechanics, and kind of coming into like this first introductory video, which I'll add onto Husky CT. But Newtonian, we're going to quickly jump into like Lagrangian mechanics, where we're dealing with kinetic and potential energy and work done on the system, where energy is a scalar system rather than vector-based math, which has a lot of benefits as you're trying to like build equations of motion and understand like what models of motion are important. At the end of the day, it saves some work here and then introduces other work in other places, but it's a great way to kind of reframe how you're approaching these kind of dynamics problems. And back to the syllabus. And I have two textbooks linked here. One is this O'Reilly Computational Dynamics, and let's see. We should be able to say read now. No? Oh, sign in. Okay, let me sign in. And affiliated with a school. Sign in here. Let's see how this goes. So now I should have access. Okay, cool. Yeah, as I was talking about this, I was thinking like, I wonder if we do still have access. So we do. And here it just brought me into this first part of like kinematic modeling of multibody dynamic stuff. And this is a nice problem for one of the smaller problems you can do for trying to model kinematics of motion, where you're actually considering each one of these moving parts. And so this textbook is great, and then this one is more recommended. If anyone has like, if you have someone buying these textbooks for you, definitely have them buy this one for you. It's required in that sense. But if not, and it's $30. It's a great introduction to Lagrangian mechanics and kind of has lots of example problems and stuff. And then these are also like introduction to calculus of variations, and then this advanced engineering dynamics. This one sticks mostly to Newtonian mechanics, but it has a lot of great engineering like problems in there. So we are going to use Julia and Pluto as part of our like coding to learn dynamics. So we're going to be using Julia code and then Pluto notebooks to kind of describe what the process is. But the goal is to actually like learn dynamics, not to become Julia coders. It's great if we pick up some Julia and hopefully we'll learn some, but I'm not expecting you to become proficient at a brand new language, and part of the fun will be like learning some new stuff there. So let's grab, can I grab this one? So I'm just gonna pop open Julia, and then I think I say using Pluto. And then, is it Pluto? No. Run? I even forgot how to run Pluto. Pluto.run. Oh my god. Import Pluto, then Pluto.run. I was close, right? Okay, cool. So now I've got Pluto open. This is kind of a cool thing that I can do, is here in this equations of motion, do I want to do this one? Let's do brachistochrone, because this is one of the videos that I had just worked on, like looking at. Brachistochrone was this problem, well, I mean, you can watch the video, but the idea is like, by varying the path between 2 points, so from here 0, 1, so 1 meter up at 0 meters forward, and then 1 meter later at 0 meter height, how fast can I get down there? So if I change, like, if I make a parabola and change where it goes through the center, right at the halfway point, then those are 3 data points, so it fixes the line. I can look at how fast different paths took. So if I want to play around with this, I could grab this. Where is it? It should have a link right in here. What? Where did it go? Let me just grab it. I'll try to figure out the link to this, but let's put this one in here. Because I think when you post a link to a notebook like that, it directly opens it right in here. So now I've got this notebook where I can start interacting with it. I'm gonna say run the notebook code. It's like, hey, are you sure? It could be malicious. I made this notebook, so it's not malicious. It's not trying to steal anything. And it won't steal anything from you either. It's not like it's just safe for me. It's just warning you that yes, because you downloaded from online, there might be something wrong with it. Okay, cool. And there we go. So it just ran everything. One thing that is, so if you've used Jupyter before, you've probably run into the problem where you change something. Let's see, what do I want to change? Like if I wanted to change gravity, let's do that. So if I wanted to do gravity on the moon, I think it's 1/5. And then when I run that, in Jupyter, nothing would change. But in Julia for Pluto, it goes through and figures out like what were the things that depended on G, like this one did and then because that one did, this one did, and then this one uses it, and it recalculates everything, and I get a whole new, doesn't look very different, but I get a different time versus fixed Y position. So it reran everything based on that change in gravity. And I think the moon, I think it's 1/5. It might be 1/6 or something, I forget. I forget exactly what it is, but then I can change it back and then it goes back to what it was there. And so then there's also like these live docs. So if I take a look at plot, it'll show me how to use plot. So here, like if I want to make 2 different plots and keep adding it to there, it'll show me that. And then T-array, this one's it's trying to show me like what that T-array was. Let's see some other, like function. Live doc. So then it's telling me like, okay, here's function, and it's showing me how to create functions in in Julia this way. Then I thought status, live docs. I thought there was another way. Maybe not. I thought there was a way to, let me delete that. Also introduce AI suggestions. So if you want, and again, our goal is not become experts in Julia. Our goal is to use Julia to help us. So it's fine to use AI as you're using AI in like building things. Make sure you're documenting like what the prompts were and how you're actually prompting them. And as we keep trying things, I'll show some examples of like how to document that AI. But just keep that in mind. Like if AI is part of your workflow and you're using it and it's helping you do work, helping you get these things done, then make sure you're documenting. And in general, my advice is copy, paste, improve. So if you are copying and pasting AI work, it's fine. Like you did some prompting and you're pasting something that you think is going to work. Make sure you're doing something to improve that you're not just totally writing off your work and saying like, I'm sure it's right. So copy, paste, improve. Always think about that. So that's launching Pluto. And so with Pluto, here, installing. So main steps to getting Pluto up and running is, so this is something we don't have like a virtual desktop or anything running Julia and Pluto. So you do have to download, okay, let's go here. If you're on Mac or Linux, you can grab this and copy. Remember, I had just loaded up this, your terminal. You would paste it into the terminal and run that. And it's a two-step process. Curl is just a fancy way of downloading something, and then sh is running what it just downloaded. So if I go to this website, yeah, this is all it is. A script, a long one, but it's just something saying, hey, computer, run this, then run this. So it makes it nice, pretty easy. If you are on Windows, it's the same. You still need to use your install Julia using MSIX, or you can open this command prompt and install it that way. So you would open up that there, or you can. Oh yeah, there's a Julia app installer. You can do it that way too, MSIX. I haven't used that. I haven't used Windows in a long time, but let me know how it goes. Julia also has awesome community, so if we run into problems, we can always reach out and figure out like how to get things going. That's the nice part about doing open source work, is that you're not just a user. As soon as you download it, you're also a developer. So you're directly connected to the next step and guiding what's important in the program. I should go star them on GitHub since I'm using them, right? Oh, it's already starred. Okay. But Pluto, maybe I should go star Pluto. Is that in here? Let's star them too, so they get some. Yeah, once you have Julia up and running, you can run Julia and say import Pluto and then pluto.run. before installing things in Julia is, let's stop our Julia. You use the, it's hard to see that one. So I'm using this bracket inside Julia. So when you hit bracket, it goes into this thing that says PKG, which is package. So now I can say things like add Pluto. And this one is going to say like, okay, look, nothing really to do because it's already installed. But if I was trying to install anything else, like add data frames, now it'll go through, look for it, and then install that. Yep, and that's it. And then once you're done that, you can hit backspace, and you're back into the regular Julia prompt. So now I can say stuff like 3 times 2, and it'll tell me 6. Cool. So that's Julia. That's where we're going with the class, is building some Julia stuff. So we're going to use some Pluto notebooks so that we can keep track of like what we're thinking. Like in this one, we have a combination of a video and then also like some equations to kind of guide us of like where we're going with this, and then finally some graphs to think about it. And that is what we have so far. There's plenty more to come, but to start, I'm reviewing our discussion so far, and then I'll start scheduling some more live streams, and then we'll have more content to talk about next steps of like building some models and thinking about physics and all of this. Cool. Thanks so much for joining, and I will catch you next time.